Welcome to the second session of number system, and majorly we will discuss on rational numbers. Rational numbers, we will revisit the classification, how we arrived at a rational number. So real numbers is a big family, real number. So in number system you will get real numbers, and those are classified as rational and irrational. So rational number is classified as integers and fraction. Integers like 1, 2, 3, fraction like 0.3, 1 by 3, 4 by 6, minus 4 by 6, minus 100 by 2. Sorry, that will be integer, minus 50. So integer and fraction. Integers are further classified as whole number and natural numbers, and negative integers. So this is entire classification. Now from here on we will move further. So this was the classification. To refresh what we are going to do. Now rational number, it is represented by Q symbol. So for natural number it was N, whole number W, integer Z. Similarly for rational number it is Q. And so this is rational number. The name comes from ratio, and Q comes from quotient. So ratio and quotient, these are. So for rational number, the standard definition is numbers which can be represented by ratio of two integers, numerator and denominator. So Q equals to x by y, where x and y are integers. Y can't be 0. Why can't be 0? Because 1 by 0 is infinite, 2 by 0 is infinite, minus 5 by 0 is minus infinite. So denominator can't be 0. Denominator can't be 0. On number line we know that where we have an idea about where these numbers are, but we don't know the exact location where these numbers will be. So infinite, whenever there is chance of infinity coming into picture, we become cautious, become very cautious. So these two are the extreme ends. Infinity minus infinity. And if you are putting your quotient 0, then only these two numbers will come. So be cautious. We should not have these two numbers. So denominator can't be 0. This is the standard definition of rational numbers. Any number which can be represented by ratio of two integers, numerator and denominator, that is rational number. Denominator can't be 0. For example, 5 by 7, all these examples. So rational number can be positive, negative also. All integers are rational numbers. Integers are rational numbers with denominator as 1. 5 is 5 by 1. Minus 10 is minus 10 by 1. 0 at 0 by 1. So 0 is also rational number. These are the question you need to remember. These are the concepts you need to remember. And some objective questions may come. And these may come in your 10th exam, in your school exam, in your college exam. While solving calculus problem, you need to understand these concepts. Very important concept, very easy to understand, but we forget. Rather than forgetting, we don't pay attention. Okay, you need to pay attention. Very delicate things like our breathe. Very easy to take, no effort is required, but very important. Similarly, this topic very easy to understand, no more effort required, but very delicate. 0 is also a rational number. Remember, all integers are rational numbers. P by Q, Q is 1. But all rational numbers are not integers. 5 by 7 is a rational number but not integer. So in logical reasoning question it may come that all integers are rational number, but reverse is not true. So you need to remember, reverse is not true. Very delicate things, students. Remember this, many big people, those are doing PhD and all, are not clear about these concepts. So please, now next question is, what is the largest rational number? What is the largest rational number? Infinity? But we can't write that. We don't know about, we don't have any exact location on number line. So we can't say, I don't know what is the largest rational number. I have just idea that it will be infinity, smallest will be minus infinity. I have just an idea. I don't know the exact location. I just have the idea only. Okay? So on number line, I will touch upon this topic in great detail. So 0, I know the location, 0 location, where is 0? This is number line. This is minus infinity, leftward, this is infinity. But I am just indicating that this is at the end of number line. But we don't know the end of number line, where it is. That's why we are very cautious. We can indicate, okay, we can indicate, but we can't locate. We can indicate, we can't locate. Indicate, very far. Where? Can't say. We can indicate only. Yeah, only is required. We can't locate. So, someone asks you, where is your friend? He must be in the school. But where exactly in the school? Classroom, playground, library. So if you can locate, then there is some definite things. We can't locate minus infinity and infinity. We can only indicate where they may lie. Okay, so that's why we are very cautious about infinity and minus infinity, and we never say that what is the largest rational number, what is the smallest rational number. Now, this is standard bookish definition. The number of the form P by Q, where P and Q are integers and Q is not equal to 0, are known as a rational number. This is the standard definition. P divided by Q. Q can't be 0. P can be positive, P can be negative. 5 by 7, 5 by 1, that is 5. 6 by 7, minus 6 by 7, minus 6 by 1, that is minus 6. All integers including 0 are rational numbers. You can't have 0 in the denominator. In the denominator, you can't have 0. Because that will become infinity and minus infinity, and we have discussed about that. We can only indicate, we can't locate. Now this is one advanced topic. If you don't understand, please don't get bothered. We will touch upon this. So that was the set system. How to write that in set system. Now equivalent rational number. This is very easy and we must understand this. X by y is equal to a by b, then those two are equivalent. Equivalent means equal. If we multiply the numerator and denominator of the rational number by the same number, the new rational number is called as equivalent natural number. We will see examples. Let's see the example. So 15 by 2. And now what you are doing, multiply numerator and denominator by 4. So 60 by 8. So 15 by 2 and 60 by 8 are same because we have multiplied by the same number. So these are equivalent numbers. Equivalent rational numbers. So what does it say? You multiply by equal things in the numerator and denominator, things are same. Rational number will be same. There is no difference. 7 equal to 7 by 1. Now multiply by 3 and 3. Top and bottom, 21 by 3. So hence 7 and 21 by 3 are equivalent numbers. I will give some exercise also. Later on I will share some exercises so that you can refresh these topics. Very easy to understand, very easy to score, but we lose attention. Okay, we should not lose attention. Now next definition, if we divide the numerator and denominator of the rational number by same number, the new rational number is called as equivalent natural number. See, these are very basic topic. Even student of class 3, like 8-year-old, 9-year-old can understand if they pay attention. So this should not be in the grade 10. This topic should be in class 4th, 5th. Very easy to understand. We just lose the focus. So we divided by 3 in top and bottom. We got 24 by 6 is 8 by 2 now. So 24 by 6, that is 4, and 8 by 2, that is 4, are equivalent rational numbers. So rational number equivalent becomes equivalent if you multiply or divide by same numbers in top and bottom. Similarly 10 by 20. 10 divided by 10 and 20 divided by 10. Top and bottom divide by same number. One divided by 2. Hence 10 by 20 and 1 by 2 are equivalent rational numbers. So very easy to understand. Slowly, don't miss any topic. If you feel that somewhere you are not getting, please write to me in the comment box. These are very easy to understand, but based on these concepts, easy concepts, will build a great foundation. Number system is easy to understand and you can get big dividend while dealing with tough problems. So multiply and divide the numerator and denominator by the same number, you will get equivalent rational numbers. Now some questions may come. Are these equivalent numbers? Yes, no, like that. Easy questions. Now based on similar concept comes simplest form of a rational number. So we have understood that a rational number can have various forms, various equivalent forms. You can keep on multiplying many numbers. 1, 2, 3, multiply. Suppose 5 by 3 is there. You can multiply 1. You can multiply 2 to both. You can get many numbers. So it can have many forms. But what is the simplest form? That is we are going to do. So first we will understand what are the prime numbers. Factors, every number has factors. Like 24 comes in table of 1, 2, 3, 4, 6, 8, 12, 24. So all these numbers are its factor. In whichever table it comes, those numbers becomes factor of 24. 7 has only 2 factors, 1 and 7. So whenever the only factor are 1 and the number itself, then that number is called prime number. Like in case of 7, only 1 and 7 are the factors. Hence, it is called prime number. Similarly, 5, only 1 and 5 are the factors because 5 comes only on 2 tables, 1 and 5. Similarly 13. Only 1 and 13. So these are prime numbers. 23. 1 and 23. So these are the prime numbers. So you got to know prime number. Now co-prime numbers. So what are co-prime numbers? So other than 1, no other common factors. We know that 1 is factor of everything, because in 1's table every number comes, every integer comes. So no other common factor other than 1. So suppose 14 and 21. 1, 2, 7. 1, 3, 7 and 21. So over here 2 common factors are there. So it's not co-prime. 14 and 21 are not co-prime. So these two are not co-prime because we have common factors 1 and 7. So these are not co-prime numbers. Now we will look at some co-prime numbers example. 15 and 16. 15, one table, third table and 5 table and 15th table. It comes in these tables. 16 comes in 1 table, 2 table, 4 table, 8 tables, 16 table. Now you can see that only 1 is common factor. Hence 15 and 16 are now co-prime numbers. These are not prime number. 15 and 16 are not prime number, but these two together are called as co-prime number. So it might be possible that one number is not prime, but when compared with other numbers, it may become the co-prime number. Like 15 and 16 are not prime because 15 has more than 2 factors. 16 also has more than 2 factors. But taken together, 15 and 16 are co-prime. So we have what we have understood: factors, definition of factor, what is prime number, and what are co-prime number. These concepts: factor, prime number, co-prime numbers. What are co-prime numbers, what are not co-prime numbers. Also one more concept we learned: common factor. So look at the common factor and say that whether these are co-prime or not. So what are co-prime and what are not co-prime? Very important concept, very easy to understand, very vital. Tomorrow you are going to use this. So 20. Now take another example, 20 and 9. So these two are not 20, 1, 2, 4, 5, 10, 20. 9, 1, 2, 1, 3, 9. So common is only 1. Hence 20 and 9 are co-prime numbers. So we have learned co-prime numbers. So now prime number, co-prime number. Rational numbers are said to be in the simplest form if numerator and denominator are co-prime numbers. So there is no common factor other than 1 of numerator and denominator. So that is called the simplest form. We have learned simplest form. We will use it in our further discussion. So 6 by 5. 1, 2, 3 and 6. 5, 1, 5. So only common is 1. Hence 6 by 5 is in its simplest form. If you multiply 6 by 1 and 5 by 2, 5 by 1 also, 6 by 2 and 5 also by 2, that become 12 by 10. Hence 12 by 10 is not in its simplest form. Like 20 by 50. 1, 2, 4, 5, 10 and 20. 1, 2, 5, 10, 25 and 50. 2 is common, 5 is common, 10 is common. So it has many common factors other than 1. Hence 20 by 50 is not in simplest form. It is not in its simplest form. So many questions can come from this topic. I will, in further subsequent lecture, I will give you some examples also how to do this. So 20 by 50, you can write that as 1 cross 2 cross 2 cross 5. That is factorization. I will touch upon this also. I am just showing over here for example, and you can cut 2, 2, 5, 5. Now it becomes 2 by 5. Now this is a simplest form. You can look at their factors 1 and 2, 1 and 5. Only common factor is 1. Hence, this is in its simplest form. When common factors are not there, then only we can say that this is in simplest form. Easy to understand, but you need to remember these things by practicing. 40 by 30. 40, 1, 2, 4, 8, 16, sorry, 10, 20. 1, 2, 3 also, 5 also, 6, 10, 15, 30. Now too many common factors. 1, 2, 10, oh 5 is also common, I forgot, no problem. So 2 into 2 into 2, 8 times 5, 40, 2 into 3, 2 times 3 times 5. What are the common? Cut them. Now the final is 4 by 3. So this is how to simplify a rational number. This is the simplest form. Write down all the, so factorize it and cancel out the common factors. This is the simplest form. So you can ask to be whether these numbers are in simplest form or not. One question. Second, convert that into simplest form. Second question. Convert these into equivalent form. Third question. So three kind of questions can come from here. I will touch upon those questions in subsequent lectures. These are easy. Whatever we have studied, I will cover those.